Welcome to the piping and sheet metal tutorial. Today I will share to those pipe fabricators and pipe fitters as well who are interested to know how to calculate LATERAL-Y branch. Now, I know some of you guys keeping a formula given from colleagues or coworkers and friends, but many of those cannot use it. And why? It is because you're having a sequence of a derived formula which is not compatible on your scientific calculator. And I have here some derived formulas according to the models and series of a Casio calculator. Let me show you how and why. But before I start, let me explain first. And this is the example of a LATERAL-Y. We have here a branch pipe of a 6-inch. The branch is diameter is the 6-inch, and the header diameter is the 8-inch. And why we have a 77, the inside diameter of the pipe? It's because we consider this example a schedule 46 inches pipe, and the thickness is equals to 7 mm. So the outside diameter of this branch for the 6-inch is a 168. Then minus 7 plus 7 again, minus 14. Then you divide it into, that's why we have a 77, the inside reduce of the branch. So the reduce is 110 for the outside of the header. That is 220, then you divide it into 2. That's why our head reduce is 110. But for the header, we have to consider this outside diameter. This is in 8-inch. Then we divide into by a circle or a branch. We divide into 30 degrees. We have started from 0, 30, 60, 90, 160. 90, then 60. Again from here, then 30, then go back to 0. And for this, we use this angle to calculate using angle and the given radius of the header and the branch. Like for example this, I have here this Casio FX99 1S Plus, and this is the first derived formula. And this 30, 60, 90, this is the sine theta here. Sine theta. First we use this 30, and the next is 60, then also 90. That's why I wrote it here. You have to answer this 30. The height, this is 30 coming from here. If we use this 30 degrees, this is now the height of this, from this tangent here to here. We have to answer, and we use this one, we can find this height or measurement. Then again for the 60, and this is for the 60. this is 30, and for the 60, and again for the 90, and this is the same also here, and here this is the same for the other side. And no need to start from the beginning again. You just change this theta into this. Start from 30, 60, and again 90. And I will do this example just only for this. Just only copy the rest, because maybe your calculator will be the same, this model. And the next is, if you do it by a pattern, so you have to calculate the circumference of your branch. So your branch is an outside diameter of 168. It's because we take the outside diameter for the circumference. So 168 times pi 3.1416 equals, we have 527. So you have to put a 527 here. So let me write first. So this one, OD equals 168, the OD of the 6 inch. So then, since you divide this a whole circle into by 30, so that means 1, 2, 3, 4, 5, 6, then plus the other side. So your 360 degrees, a whole circle, you divide it into 30 degrees. So 360 degrees, a whole circle divided by 30. So you come up with the answer of 12. So this circumference, or this 527, you divide it into 12. You make 12 equal parts here. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. So now this is your 0. This is the 0, and this is also the 0. And this is the second line, so this is the 30 degrees. And this is also the 30. And 60, 60, 90, 90, and go back to 60, 60, then 30, then 30, and this is 0 again. So this is 527. So let us try using this derived formula. So our header radius is the 110, the outside. So let's put the 110. then minus the square root of head radius squared of 110 and squared minus the branch radius, the inside, minus the branch radius of 77 squared times sine theta, which is we use this 30 because 0, this is nothing, times sine theta 30 degrees, then you have to close, then squared equals. So the answer is the 7 mm, 6.9 or 7. So this is 7. And for the next is just only change the degrees. So we have to change into, next is the 60, so that we can find this dimension. So you have to change it into 60, and the answer is 22.5, or let us say 22. And the next, the 90, and the answer is 31. So now we have already the answer. For this distance here, we have a 7, and for the 60 degrees we have the 22, and 90 we have this 31. So now this is the circumference of the header, which is 168 times pi, or 3.1416, or 3.14. So this is let us say this is 527. And this start with the 0, this is 0. And for the 30 degrees, let us say we have to measure from, this is our baseline. So we have to put a measurement 7 mm. Let us say this is 7 mm from our baseline. And again, 7 for the other side. No, this is 0. This is 7 here, 30. And for the 60, we have 22. Let us say this is 22, and also 22 here. And for the 90, this is 31. So 31, let us say this is 31. Approximate only. And for the 60 is 22. So we'll say 60 here, 22. Here also 22. And for the 30, this is 7. 7 also here, 7. And for the 30, this is 7 also here. And this is the 0. 0, this is nothing. So now we can make a projection from here, 0. Start from the 0, you have to can make a projection line. So finally, you have now a pattern, and this pattern, this baseline, this is now your line, this is the line. And how much will be your measurement from here? Let us say you have here a 300, so you can now add a 300 from here and here, and make a line. And now this is your pattern. So it is a very simple calculation. And for my next video, don't forget to subscribe my channel, and that's all.